So today we're going to be doing a quick video talking about Unreal Engine 4 and shader compilation and how to mitigate this in certain titles. So at a glance, most Unreal Engine 4 games will use DX12 as the primary renderer, and I believe the reason for this is it's just the easiest to work with for the developers, but the problem is that using DX12 can create shader compilation issues. So what we're going to do is use Hellblade as an example for this. So I've capped the frame rate to 120 and made sure that we are not going to be GPU limited in any way. So what I'm going to expect to happen is when we load into the game and load up a level, we are going to have stutters every time a new effect appears on screen. So what we are looking for is a frame time graph that is completely flat like it is at the moment. You'll note that as I spin the camera, we get loads of stutters as these new shaders are being generated. If we spin the camera again though, the stutters don't occur. The shader stutters only occur once, so what we are aiming to try and do is stop these stutters from occurring. And you'll notice as we walk around, as we move the camera, as new things are loaded, these stutters are very prevalent throughout playing this game. Every time we're moving forward, like new effects are being loaded, distant objects, things in the distance. If we spin the camera again, yeah, we have stutters. It's not a nice experience, and this frame time graph should be completely flat. There should be no stutters at all. So what we'll do is we'll talk about how we need to fix this and how we can sort of sort this for any Unreal Engine 4 games, but just using Hellblade as an example. So what we need to start off doing is switching the DirectX version. So at the moment in the top left it says D3D12, that's DirectX 12. What we need to do is put it into DX11 mode, as that's where we can combat these shader compilation stutters. Some games you can change the DX value in the settings. For example here, we can set DX11 and apply that, and then we would have to restart the game to apply that change. Some games you have to go into the config arguments and basically specify the version that you want to use. So if a game, for example, didn't have that option, you go to Steam settings, properties, and then type in the version you want here, like that for DX11, and then DX12 is that. But for obviously this case, we've already set it to DX11 in the game. So next time we were to relaunch the game, it would open up successfully in DX11. The problem with this, though, is it still does not combat our shader problem. So what we need to do is go into the app data directory. So if we go C users, app data, local, and then find the game in question. So in this case, it's Hellblade. Saved, config, Windows no editor, and then open up the Engine.ini file. And within here, what we want to do is add a string of text, which is as shown on screen here. We would then save the file and go to relaunch the game. And what we've done is we've told Hellblade to run in DX11 and to compile shaders on load. So what that does is instead of the stuttering occurring when you're spinning the camera when the objects are loaded, it compiles the shaders when the level is loaded. So in a second, once the game loads, we should now see that the CPU will light up with all the threads rendering these shaders all at once, instead of them causing stutter upon when a new animation or object is loaded into screen. So if we go back to the same level as before, you'll see that the CPU is absolutely going for it as these shaders are compiled, and we'll give it a second to calm down. So now that the shaders have been compiled, what we can do is we can spin the camera, and you'll see that there are no stutters. We'll then walk through this doorway, same as we did on the previous level, and if you remember, it was stuttering. You still may get the odd one as it does load. It doesn't catch everything, unfortunately, but it grabs the bulk majority of the shaders that it will need when playing and using this setup. So we'll walk to roughly about the same spot, spin the camera, and it is completely smooth. There is no stutters at all. It's basically completely gone now. But as shown a moment ago, if you do continue to proceed, anywhere that you go that is new shaders have to be compiled. So if we were to go back to the main menu and load up a different chapter, you'll see here that the CPU goes to 100%, and it will sit here for quite some time. So anywhere that you go into that is a new area in the world or a new level, it will have to do this compilation step, but at the cost of it being dead smooth when you spin the camera. There might be still the odd stutter, but it's much better than it would have been previously. And as I say, this can be done for any Unreal Engine 4 game. To conclude, that is how you modify an Unreal Engine 4 game to compile shaders on load. Thanks for watching.